database, what we're working with is, this was our RDS instance that we're talking, that we've seen before. And, we're something like Postgres. And typically, right, like what this is used for is like a website or an API that has a lot of inserts, deletes, a lot of what we call transactions. So what would be this? Like basically any website you generally interact with online. Especially like any kind of e-commerce website where the transaction might be either like a login if they're storing that, or even more classically just like a purchase. Twitter, Facebook, right? What is the transactions there? Well, making posts, right? Adding a friend, etc. Those types of databases have a lot of, read and write transactions. They have to occur pretty quickly if you think about the number of users that we have for that. They're also very, and we'll talk about this more later, they're very like row based. Like if you think about going to a person's profile on Facebook, what do you want to see about that person? Well, like almost all the information, right? Like you could imagine select all from users, right? Like, or select all from users where the ID equals, specific ID, because you want to get all the columns of, of that user in order to fill in information about their profile. When we move to like analytical queries, you probably don't really care about like an individual user. What you care about is something in the aggregate. So instead of caring about like somebody's name, that's probably not very useful. But maybe what is useful is like what's the average age. So for that, right, like a specific column is what's going to be more what we're going to be querying, right? Maybe select all the users or the most recent active users. But just really care about a few columns of data as opposed to the entire row. So we'll see like that will change, our queries and also the underlying hardware of the databases that we use. So again, our transactional database, this is what backs an API or backs a website, right? That like consumers use on the internet. Our analytical database, this is going to be for internal use, right? Like the marketing team or operations or finance team wants to see where the money's coming from or have certain projections, right? Or make sure that people that they're getting paid, right? Things like that. In order to move the data from one place to the other, we'll be using this tool Airflow, right? Which you can see, this is our orchestrator. And the pipeline that we'll eventually get into is, okay, like take the data from an RDS instance, upload it to S3, and then move it to our analytical database of Redshift. And then you can see, from there we can pull it into a query our analytical database from a business intelligence tool, meaning like a dashboard, like Mode or Tableau. All right, so we'll be walking through this, but I just wanted to give you like an overview as to what this next unit is going to be about. All right, so the next thing that we'll do, there's a reading on this obviously, but what we'll kind of focus on today is just really first, reviewing transactional databases and the structure of them, right? So far, that's really all we've seen. And then we'll get into the difference in terms of structuring our tables with analytical databases and why we'll structure them differently. All right. So just to review, with transactional databases, like the main thing that we've talked about is just maintaining a single source of truth. Okay. So for example, we don't want to store a given actor's name in more than one location, right? Like if we're representing this one actress or actor, right? Like their first name, their last name, like that's only stored in one place, in one location in the database. Typically, like you can any question or any query, that information should only be represented once in a database. So for example, you can see here with our join table, right, we're not repeating obviously the actor's name. Instead, we're just having a foreign key that points to the actor. Same thing with the film ID. As we'll see, like that we'll relax that rule when we get to analytical databases. But for transactional databases, and really like the default that you should all be most familiar with is knowing how to structure, our OLTPs, This stands for Online Transactional Processing Database, our OLTP databases. And for that, right, we want to maintain this single source of truth. Okay, so the other thing about the way that we structure this is, and this is another way that you'll hear about this data modeling form, meaning like what does our schema look like and what rules are we following in designing our schema, is that, right, this is a third normal form. And the definition of third normal form, there's a lot of definitions, but the one I like is every non-key attribute, okay, meaning like we would say this is the actor ID, the film ID, these are key attributes, right? These are the foreign keys. This is the primary key of this table. So every non-key attribute must provide a fact about the key, the whole key, and nothing but the key. All right, so this is, again, what we've been working with so far. So let's see if we adhere to this rule. So if you look at the actors table, right, all of the non-key attributes, that would be the first name and the last name, right? This is kind of some metadata thing. But the first name and last name, these are non-key attributes because it's not the primary key or a foreign key. And this provides a fact, right, some information about the key, right, the whole key and nothing but the key, right? So each of these point to the actor ID. So this is a good way for you to check, right, when you design your schemas that you're following third normal form. Again, if you look at the film actor table, right, our join table, just notice, right, there are no non-key attributes. So if we relax this rule, if say we were breaking this rule, we would have like the actor's name here, right? And that would be a non-key attribute that is not really about, this table really describes like a film role, right? But it's not the case that if you have the actor's name, it's about the key, the whole key, and nothing but the key, right? It's also about then the actor. So this is like a good way to check this. You can look at a column and say, a non-key attribute. So one of these columns say, does this provide information about the key, meaning the primary key, the key, the whole key, and nothing but the key, right? This only describes our actor. If you have a film name here, it not only describes the role, but it also describes, right, the film itself. So, one thing about that I say, like, here is like it gives us this tightly coupled information. Everything just points to that primary key, ideally. One byproduct of these rules is that this tends to lead to small tables, like lots. By that I mean tables that have a few number of columns, okay? And this works out for a transactional database because our transactional database, as we said, we're like insert and updating a single row at a time. And if if we're updating a row of information in the table and there's only 5 columns there, or 5 to 7 columns, that's not a lot of data of columns that we have to update at once, right? We can just, when someone signs up, fills out a form, and we update 5 attributes about them, right? Like that's, we can perform that transaction relatively quickly, as opposed to, as we'll see, like our analytical databases will tend to be bigger, all right? But when we have these rules about like, okay, every column has to point to the key, the whole key, nothing but the key, that leads to small number of columns in a given table. All right, so you can see like 5 to 7 columns. That's really what we're talking about with a transactional database. All right. So this is what I want you to, what we'll do is we'll do a modeling exercise. We haven't done this in a little while, right? We kind of saw it with object-oriented programming. We saw it when we did the Foursquare lab and moved through that. But it's like, okay, how do we, given a domain, how do we model our tables? What columns and what are the names of the tables and what columns go in each table, right? Like that comes up a lot, both in your job and in interviews. All right. So far, all you have to worry about is modeling transactional databases, meaning the ones we've seen so far. Okay. Just to give you a sneak peek, right? Like this is an OLTP database, right? You can see that we have lots of smaller tables. And then what we'll move into is an analytical database where you can see like fewer tables, right? And it's we have more columns, and we'll be relaxing our rules that we saw in the previous, that I was just talking about. Okay. Right. This one we have like a separate table for city, zip code, state, and address. Each of these get a separate table, whereas here, for whatever reason we'll talk about in the analytical database, we'll combine that information. All right. So we'll relax our third normal form rules. Questions about this, like the data modeling part, especially, about OLTPs. This is really valuable. Like knowing how to model. Well, we're about to do an exercise on it, but feeling comfortable about what are the rules with modeling data, right? And that's this single source of truth and, this kind of check that you can provide. All right, well, let me tell you what I'll have you do next, and that will be doing some modeling practice. So, I say, hey, imagine we design a database schema for a commercial airline. So let's just, this could be super complex. So just keep track of the pilots on a given flight. So our system should tell us what flights are planned in the future and which pilots are flying each plane. Okay, so already it's like if I were to ask you, okay, what are the various tables involved? What are the columns that we care about? The main ones I would care about, that like you really want to focus on are going to be the, cool, let's start to get into this. So, right, so we have this, this problem of we have pilot and then we have, flights. Like I generally, when I do these data modeling problems, like here, obviously we're going to expand the number of tables here. But what I do is I'll just kind of like start with like, what's the event, that occurs? Like that's kind of the first thing I'll generally think about, so like, what's the event here that occurs? It's kind of like a flight, right? Like a flight taking off. And then you can start to think of, okay, what's involved with a flight like taking off? Okay, so for a flight, maybe we have, the, just like primary key. Okay, where is it taking off from? This actually is not very good, right? The city, because a flight really goes to like an airport. So it probably should be like either airport ID or just origin ID, and that represents an airport, and then the destination, airport ID. Then from there, right, I'd probably think about like, okay, well, the flight is, we have at least one pilot here. We said that there could be two, but probably no more than two. So you could have, co-pilot maybe here. What else? So we have the flight, and then at a given time, right? Like a flight takes off at some sort of date time. All right. So you might start there, and then for me, I would think about, okay, now, if I have many flights, what starts to get repeated? Like if I just now start to think about like an Excel spreadsheet of, we have this flight ID number 1 or whatever it is, from LaGuardia over to, Philadelphia. Like you can, and then you have a second flight. Well, you might start to think, hey, well, we're actually going to have multiple flights, right, that have the same origin and destination, right? And this is like a route, right? So you just start to, what I'll do again is I'll start with like, what's the transaction, right? So here it's like the flight, right? This is the event that's going to occur lots of times, and then start to just build it out. And then I'll start to kind of like test this by thinking, okay, what goes wrong if I have multiple flights? And by what goes wrong, I mean, what starts to get repeated? So what you'll see is, okay, we have LaGuardia in Philadelphia, that happens, let's say on June 8th, at 10 a.m. or something. And then we have another, this happens again, maybe on June 9th, but it's a different flight. So now we have repeated information, right? We're violating our single source of truth. And there's an idea here, right, that this is a route, okay? So really what we do is now we'd start to break this out and say, okay, well, maybe I have a route, and a route has an origin and a destination, right? And then a flight is associated, instead of these two things, a flight is associated with a route ID. Okay? And then we'd have, maybe we can move this data up and say, okay, well, a flight has, a route, a pilot, maybe a co-pilot, a date, time. And then again, like I just start to think about, okay, what can go wrong with a flight? Like, are any of these columns, like, can they change, or anything any information I might be missing? So for me, the thing that I started to think about was like, all right, well, like, what if the flight is delayed? Like, how do I capture that? And a flight might be delayed many times. So one, you could even just have a delays table. But the other thing I'm thinking of is, like, we have this information about the flight, like, plan, and then we have the actual flight that occurred, So this is, maybe I have this is like actually the flight schedule. And I have the ID and the route, where is it, what's the route, who's like planned for the pilot, and what's like the takeoff time, right? And maybe they have like planned takeoff, planned land, or something like that. But then here we have the actual flight, right? And again, here, the route is probably the same. We probably don't need this, right? We can just maybe point to the flight schedule ID, and that would contain, and we probably should. Right, so a flight is associated with like the planned schedule, and then, this is the actual takeoff. What I care about is the actual takeoff and the actual landing time, right? And again, I just keep thinking, like, what can go wrong? Like, what might change and where am I not capturing data? So one thing I thought about was like, all right, well, in between what I plan of the pilot and actually who's piloting the plane, right, that might change over time. Like somebody gets sick or whatever. And like as an airport, like, or an airline, I want to keep track of that. So, and I don't know how many times it's going to happen, right? So it could happen a lot of times. So maybe what you do is you have something like, like a pilot assignment, something like that, right? That's associated with like the flight schedule. Like this is who's assigned for it. And then you can have, a set of rows. All right, first it was Bob, and then Bob got sick, so Sam, and then Sam got sick. And then finally, the last person is the person who was actually flying the plane, right? So you might have like a pilot assignment. So this would be like the flight schedule. This is who's associated with that planned flight and the pilot ID. And then, by the way, this whole thing could also happen with the plane, right? Like maybe we thought we we're going to use this one plane, but like, so this maybe is like a plane assignment, right? So we have like who we planned for the plane, and then who actually, we might be reassigning these planes. Like whether or not you store all these things, you would talk to probably like stakeholders and people that really, are involved to figure out like how valuable this is. But I think the pilot probably you definitely want to track, these different pilot assignments. The plane assignment, my guess is as well. Here again, like you're missing some stuff if you don't have something about delays, right? Like how many delays are there? And I think the other thing is just to like part of what you guys are thinking is like this seems too detailed, but I would say you want to take this stuff seriously, like in a interview or on the job. Like I would probably have a delay. I think delays is very reasonable. Of like, why is there a delay? There's probably some sort of table about like delay reason even. Right? And there's like, the description and the ID. And then a delay is associated with a flight. So you have like a flight ID and maybe like the reason ID, and the amount of time, something like that. A delay time, delay amount. I'm not sure if we'll just capture the delta. Yeah, probably just capture the delta. And so if you add up all the delays, you should get the actual takeoff and landing time, right? So, like, what I would say is, I don't know. So I'm just sketching these out, but you can see already I have, and we didn't even include, we have this plane thing, but we don't have a plane table. Oh, sorry.
What if the last minute change of the pilot will change the pilot ID too, and it will reflect to the flight? Why we need it like?
Oh, you're saying why do I need the plane assignment and here? Is this what you're
Yeah,
saying?
because if we change the pilot got sick, right?
Mm-hmm.
Last minute change of pilot will change the pilot ID primary key, which is associated with the flight schedule.
Right.
So it
So what you're saying is this shouldn't be here, right?
so e-
Yeah,
yes.
I would agree. Like this violates single source of truth. Yeah. Right. And maybe what we have is the same thing. Like Copilot, this should be like, is primary true or false or something like that. Like is Copilot, right? And that way we can have both the pilot and the Copilot here. Right. So it's the pilot assignment. We have, the flight schedule, the person, and whether they're like, sitting in the driver's seat or riding shotgun, right? And then, the last person assigned is the person who we know is actually flying the plane. Same thing. You could say the same thing with these delays. If these delays, if you add up all the delays and that leads to your takeoff time, right? This could technically violate like single source of truth because I can find out the takeoff time two different ways. Probably it's practical enough just to, like in a real life, you would probably just violate single source of truth because you just want to be able to easily find this information out. But it's possible not. I don't know. The plane assignment, right, it would go by that same logic that Polly was pointing out, right, that I don't need to store the actual plane here because the last plane assignment would be the plane that's actually being flown, right? But just to go back to my process of how I kind of think through this and how I'd recommend you thinking through it. It's like we start with just like something, basically like your transactional table, right? Which is a flight. And then you just start thinking, okay, what's getting repeated? So I think, okay, here's my flight. And then what is involved with a flight, right? And these transactions oftentimes involve many different foreign keys, right? A flight, we start with the pilot ID, like a plane ID, right? Origin city or origin airport and destination. And then you just start thinking, okay, what's wrong with this table, right? And one way to do that is to start just writing out rows and seeing what gets repeated, right? So what gets repeated is, I think right away you'll see is like the origin city and destination city, right? And that actually aligns well with this concept of route. And then the other thing you start thinking about is, okay, like as things change, like what data am I missing, So can I change the pilot or the plane? The route you're not really changing, I don't think, but the time, right? We saw that, and that led to like our delays table. So this started leading to our route table because we saw repetition there. The flight schedule, right, this flight really turned into a flight schedule of, okay, this is the plan, right? That's in place, but then there's updates to the plan, and I want to capture that data, right? We don't want to just, if you just say like, oh, now it takes off at 11 and remove the 10 a.m. and replace it with 11, you're missing information. You're missing the fact that originally it was scheduled for a certain amount of time, right? And if you're like an analytics engineer, you probably care about delays as a form of customer satisfaction and money lost, and it seems like it causes a lot of problems. All right, so we start thinking about, okay, as things change, what data would get lost, and then how do I, reconstruct this so that we're capturing the data. So what could change, right? We talked about the delays, the takeoff time. We thought through the pilot, right? That could change. We thought through the plane itself, right? That can change, right? And then finally, you have the actual occurrence, right? The actual flight, okay? You might store other things here. I don't know if you store stuff about turbulence. I don't know. That's kind of outside the scope. Maybe it's turbulence or whatever. But you can think about things that are things that where like data is lost, right? That as things change, you want to capture it. Okay. So this is like, I'd say this is very typical type of problem to see, and to certainly, like, if you're a data engineer and analytics engineer, I don't know how it's possible to avoid it. So really, like, having that strategy in mind of, all right, what's the transaction, what can go wrong as I start to like build out rows of data, what's getting repeated, and then as things change, what am I missing? All right, so you can see, pretty easily we're able to get to like 8 or 9 tables here. Cool. Questions about this?
I have a question. I mean, once we do all these tables, they're completely unconnected because you made sure they're unconnected. So is it like you think about the foreign keys later, or?
Well, I'm putting them here, like the flight schedule ID, right? A plane assignment is assigned to this, right? So this is a flight schedule has many plane assignments, right?
But that was duplicating. That's why I thought we took it off the other one.
No, we're having a pointer. Like, here's the actual flight. The flight points to the flight schedule, right? The planned flight. The delay probably should point to the probably the flight schedule. It seems like that's kind of our main tool, right? The delay reason ID points to the delay reason. So we are connecting them through our foreign keys. The plane assignment. Sorry, this should be a pilot assignment. Actually, we have pilot assignment here, but that's comes for our flight schedule ID and our pilot ID, right? So they're connected, even though we're not drawing the arrows. They're all connected through the foreign key, right? Route here we need an airports table, and that would just have like the abbreviation, and like maybe what city and state it is, something about the location and the abbreviation, their airport name. Right. But these things do connect, right, through the foreign key. Like in an interview, like they'll direct you as to you're going a little bit too far down, like we can, but to like talk through it is certainly something you want to do. Like, certainly, like, just to be like, okay, I don't know if we would need, account for the fact that we could switch out pilots, and they might say, okay, well, you can assume there's only one pilot, right? That the pilot we plan with is the ending up pilot, right? Delays, but you should raise it as a way to, because it could be that they're really looking for something like that. Okay. The other thing is, like, I think that lots of times in interviews, people don't if I give you this as an internship, like in an internship context, a lot of you would take that very seriously and be like, okay, well, let's really think through like all the things that can go wrong. But then once it comes to like the interview, sometimes you'll be like, oh, well, this is just pretend, so you won't really account for as many details, right? Or think through the details as carefully, or think about what can go wrong with the data, etc. But that's what lots of times they're really looking for is, okay, like, take this, this is a problem I dealt with in work, so I want to see the same level of care applied in an interview, right? Okay. Then the other thing was just to talk about OLAP and what's going on here. So, you can see this is the Pagilla database. By the way, like the Pagilla database, that's the lab that I'm giving you all to do in this OLTP querying lab. Just know, I think, oh, do I not have, it does say to actually clone down this repository. The other thing is, and then run this in order to create the data. The other thing is, once you create it though, you're going to have to connect to this locally. So I think I'm going to have to provide you the repo, right? This isn't going to work from Colab. So I'll provide you the repo for this so that you can clone this down. All right, but let's just get back to OLAP structure. So this is the way that you'll structure analytical databases. You oftentimes structure them differently than your transactional databases. So with transactional database, right, we're separating out, right? We're keeping things in third normal form, having only a single source of truth. So that means like we're not going to repeat the name of a city more than, it's only going to be listed once in our entire database. The name of a state is only going to be listed once in our entire database. And that means that, when you do something like a city belongs to a state, we have the state ID there instead of repeating the name of the city. And the same thing with like address has one zip code, right? And then the zip code has one city. So we're doing a lot of stuff to avoid ourselves repeating. And what that leads to is a lot of small tables, okay? You can see like when we move to this OLAP form, we can make our schema a lot simpler. Just the number of tables can really reduce. And, the reason why we might want to do that is one, we may have non-technical people. Probably that's oftentimes the case, that we're really designing these schemas for like the marketing team or operations team or et cetera. And so they don't want to perform a lot of complicated queries just for something that to them seems fairly simple, and they know what queries they're going to have to perform often. So that's one idea. The other thing is if we're working with a lot of data, those joins can be expensive, right? Joins can actually take a lot of time. And you can think through almost why, right? Like we're joining on a foreign key. So if you think of we have a primary key of one, and then we're looking for all the cases, let's kind of go over here, of where I'm looking for, this zip code, that we have a matching zip code ID of one. Well, that means we should be looking through the zip codes table, right? Again and again and again, looking for that ID of one. And then we go to the next row, and we have to find the one of two, right? So these joins of matching, finding the corresponding record, right, can become expensive. I don't want to get into that too detailed. It's almost a lesson on itself, but I am deploying a lesson, a reading on it for you to look at. So anyway, one reason is just make our schema simpler for our stakeholders. Two is reduce time expensive joins, right, to perform. And the way that we solve that is by moving to this thing called the star schema. So with the star schema, you can see, it's not ideal, but you can start to see the way that we're structuring it. In the center is this events table, all right? So in this case, it's this sales table, all right? So we can see like this is like, DVD rentals or DVD sales. And this is the transaction, right? And this is oftentimes called the fact table, all right? And it's like, again, the event that's really occurring, like the main event that's occurring. So that would be a sale. And you can see that almost everything we have here in that table is a foreign key. So the date, for example, the customer, right? The store. But it tells a story. It's like what was involved in a sale. Well, on this date, a customer walked into the store, and probably there should be a product there too, and purchased a movie, right? So that's the event that occurred, right? And that's called the fact table. The other thing in the fact table, so the fact table essentially consists of our foreign keys, the who, what, where, why, when, not why, but who, what, when, and where. And then also like a target or what we're keeping track of. So for sales, what we're keeping track of oftentimes is like revenue. So what's another good thing to store is like the price, okay? So this way we can easily kind of see, okay, if I group by customer ID, and add up the price, do the sum, we can see the revenue per customer, right? So generally everything in the fact table is numeric, because either it's going to be like a foreign key, or it's going to be something that we're trying to measure, like how much money we're bringing in. By contrast, right, we can start to see these more descriptive tables. These are called dimension tables. And like I said, this is of this event describing this purchase. Who did it? When did they do it? What did they buy? Where did they purchase it? And these things, like if you think about who purchased it, we have the first name, last name, address, zip code, city, state, right? These are more descriptive, right? Non-numeric. Same thing with like the store, right? Maybe we have, I guess, the city, state, the manager involved, but again, less likely to be numeric information. So, and then the date is oftentimes often like broken out into its own table, and you can see we're totally violating single source of truth. But it allows us to say group by the year to see, purchases just by a year. One thing you can see by doing this structure is that if I want to see, okay, like, who's our most profitable customer, that's just one table away from my sales table, right? I just have to join one table to get to the customer. Or if I want to see like the manager that had the most sales, you can group by the just join the store and then group by like the manager first name comma last name. But again, it's just one join. So the number of joins that we have to perform is less, meaning that it's less costly, right, in terms of a time perspective. And then also it's just easier for someone like a marketing person who's a little bit less technical to perform them. So that's the benefit of moving to this star schema, is it's able to, so it allows us to perform easier queries just in terms of the amount of joins we perform, we have to write out. And also, they're faster, right? And it's kind of like organized around this. Here's what we're measuring, right? Like here's what we're trying to capture is a sale, right? And figure out the data associated with it. Okay. People are relaxing this star schema. Lots of times now they're like a combination of our OLTP form and the star schema form. But these are the two paradigms, I'd say, is like break everything out and then, okay, just orient around the star schema and violate a good number of these rules, like single source of truth, or like, you can imagine a store really has multiple managers, but we're losing that here. We just have a manager first name and a manager last name here, right? We're just assuming there's just one manager, right? Why? Just to keep this stuff simpler, okay? So that's the OLAP form. It's not, I think you all, I don't know, it's not too much to it. Questions about this? Right? It's good to know. Like, certainly, some of you have probably already seen it. All right. That was fun. Let me deploy this. The OLAP, this will be on optimizing joins. Just like a little bit more about the cost involved with joins.